This is my lab 2 for Physics 2212 at Georgia Tech. First, I'll introduce the objects and its surroundings. Then I'll go over some key ideas and relevant formulae. Next, I'll go through the calculations, introduce the computational model on GlowScript, and then discuss the results of the experimental and computational model. Finally, I'll go through some discussion questions. This lab is based off lab from week 1 using charge tapes. However, this time we'll treat the charge tapes as lines and then divide each piece of tape into segments and consider each segment as its own point charge. Next, we'll use superposition of charges to approximate the charge of the tape. Key concepts for this lab. First, we have the electric force, which is given by Coulomb's law, where F is equal to K into Q1 into Q2 over R squared, where K is a Coulomb's constant. We also require the electric field for a point charge and the electric field for a line for the computational model. The other two forces involved are the force of gravity and the electrical force. Coming to the calculations, we can equate the magnitude of the gravitational force to the magnitude of the electric force of a line. So mg is equal to 1 over 4 pi epsilon into q squared over r into the root of r squared plus L over 2 the whole squared. This gives us the value of q squared to be 7.63 into 10 raised to minus 17 coulombs. Therefore, the value of the charge is 8.73 into 10 raised to minus 9 coulombs. Next is the computational model. In order to create the computational model, we must set some constants. Mass is 2 into 10 raised to minus 4 kilograms for the tape, and Q is 8.73 into 10 raised to minus 9 as given by the calculation on the previous slides. We then use the formula for electrical field to calculate the charge of the tape. In the for loop, we divide the tape into different segments and deal with each segment at its own point charge. Then we use the concept of superposition to add up the electrical fields in order to calculate the final charge of the tape. The results for the computational model. Based on the value for Q, we got the electric force to be 1.66 into 10 raised to minus 3 newtons and the gravitational force to be 1.962 into 10 raised to minus 3 newtons. It can be concluded from the computational model that if we divide the tapes into more segments, that is if we have more point charges, the accurate the model is. Key assumptions for the lab. Air resistance was ignored in the lab. The effect of air resistance on the charge tape, on the upper or the lower charge tape, is not taken into the account, nor is it included in the computational model. The segments of the long piece of tape were treated as point charges, with all the charge concentrated in the center of each of the segments. We also assumed that the total charge on the tape was evenly distributed across the tape and across each segment, allowing us to assume that the point charge was at the center of each segment. Each upper tape was assumed to have the same amount of charge every time we repeated the experiment, and there's even charge distribution across each tape. Possible sources of errors for this lab include human errors, existing charges in the surroundings, and loss of charges due to contact with the tape. Moving on to the discussion questions. What if we had modeled each of our tapes as a single point charge like we did in the previous lab? So what if we compared the estimated value of the charge that we get to the experimental data to produce a point charge model instead? And how does that compare to the line charge model that we had? So in order to treat the charge tape as a point charge, because that's what we did in the previous lab, we would equate the gravitational force to the electric force. So the magnitude of the gravitational force is equal to the magnitude of the electrical force. But instead of using the formula for the electric field of a line, we'll use the formula for the point charge, which is given by Coulomb's law. So mg is equal to 1 over 4 pi epsilon into charge divided by r squared. This gives us a value for the point charge to be 2.33 into 10 raised to minus 9 coulombs. And as we can see from our previous calculations, we got the value for Q to be 8.73 into 10 raised to minus 9. So obviously considering the whole charge tape as a point leads to a massive discrepancy. So why do these estimates differ? The point charge basically assumes that all of the charge of the tape is concentrated at its very center, whereas the line method is much more accurate as the charge is evenly distributed across the tape.